In this video, we're going to talk about simplifying algebraic expressions. So we just did the order of operations. That is what we do to evaluate a numeric expression, or numerical expression has just numbers and operations. An algebraic expression is a mathematical phrase that contains numbers, variables, and operations. So we have the variables. The way that we simplify our algebraic expressions is using two different properties. One is the distributive property. Well, the distributive property and then combining like terms, not really a property. So first let's talk about the distributive property. It allows you to multiply across a sum or a difference. So you've probably seen it written like this. And you do A times B plus A times C. That's the distributive property. So let's use it here on these two examples. So I have 2 times 3x minus 2. So this is my multiplication, 2 times what's in parentheses. The 3x minus 2 is my difference. So I'm going to distribute. I'm going to do 2 times 3x, and I'm going to write this step, although normally we do that in our head, plus 2 times the negative 2. Or you can say minus 2 times 2. So I get 6x minus 4. Now, I can't do that subtraction because the 6x has an x, it has a variable, and the 4 does not. That's our combining of like terms that we'll talk about in just a second. Let's do our second example here. This time I have a negative 10 that I'm distributing, and I'm going to skip this middle step. I'm going to do the multiplication in my head. So negative 10 times 4x, negative 10 times 4 is negative 40x, and then negative 10 times negative 8, so a negative times a negative is positive, 10 times 8 is 80. And that is all there is to the distributive property. It's one of the most important properties of algebra. We'll use it very, very, very often. So it is important that you know how to use it. Okay, let's look at the second part of combining of simplifying our algebraic expressions. So the second part involves combining like terms. So first let's write down our definition of like terms. Like terms are terms that have the same variable or variables raised to the same exponent or exponents. You can only add or subtract terms that are like terms. So if you have one term with an x and one term without an x, they can't be added. They're not like terms. Terms, by the way, are separated by addition and subtraction signs. So these are two terms right there, 4x plus 6x. These two are like terms because they both have an x to the first power. So I do 4 plus 6 is 10x. It's like saying 4 oranges plus 6 oranges gives me 10 oranges. My second example, negative 2x squared plus 3x squared. They both have x squared, x raised to the second power, so I can combine them. Negative 2 plus 3. Signs are different, so I subtract. 3 minus 2 is 1, and keep the sign of the larger, so positive. The x squared stays x squared. If you just wrote x squared, you didn't put the 1 there, that's fine too. When your coefficient is 1, we do not have to write it. Our last example, 6x plus 7x squared. So we have here 6x to the first, and we have 7x squared. These cannot be simplified, cannot be combined, because this one is x to the first, this one is x squared. They are not like terms. Now, to simplify our algebraic expressions, we do a combination of these two things. So To simplify an algebraic expression, first we use the distributive property. Distributive property is multiplication. Then we combine like terms. Combining like terms is addition and subtraction. Multiplication comes first because of our order of operations. PEMDAS. Let's work through a couple of examples. So the first one. First I want to use my distributive property. I don't need to here because I have no parentheses. So when do I use the distributive property? See my parentheses there? That tells me I need to use my distributive property. So on example 1, I do not have distributive property to use. So I look at my two terms, one term, two term, and I'm just going to combine them. So here we go. So I have p and p, so they're both the same variable raised to the same exponent. So I do -3 plus 6. I'm adding, and the signs are different. So I subtract. 6 minus 3 is 3, and keep the sign of the larger, so it's positive. And again, the p just stays p. All right, looking at example 2. In example 2, again, I don't need to use the distributive property, and I know that because I have no parentheses. So I'm going to look for my like terms. So I have the 1 and the 10. Those are both constants. They do not have a variable. I can combine them because they are like terms. Just ignore that. So 1 plus 10 is 11. And then minus 3x. There's no other x, so it's just like that. Now in algebra, we usually like our x to come first. So if you did -3x plus 11, that's probably better form, but for now, we'll just leave it right there. All right, looking at example 3. Example 3, I do need to use the distributive property. And I know I need to use the distributive properties because I have a number right outside my parentheses. So that is multiplication. Multiplication is the only operation we do that doesn't require a sign. So if I wanted this to be addition, I would need a plus sign. If I wanted it to be subtraction, I would need a subtraction sign. If I wanted it to be division, I would need a division sign or a fraction bar. Since I don't have any of those, I know it's multiplication. So here we go. I'm going to do 8 times 3x. So 8 times 3 is 24x. And then 8 times -4. So 8 times -4 is going to be a -32. Example 4. Again, distribution. Again, I know it's distribution because I have my number, -4, right next to my parentheses. That's multiplication. That's how I know I need to distribute. So I'm going to go -4 times 5 is -20. And -4 times -2x. Negative times a negative is positive. 4 times 2 is 8x. Let's go ahead and end there. We'll do example 5 and 6 together in class. And then we will continue talking about our algebraic expressions.